In session 42 here, we're going to introduce the slope-intercept form of an equation. As a reminder from several lessons ago, the standard form of a linear equation was ax plus by equals c. Well, through using algebraic strategies, you can rework an equation so that you get y all by itself on the left-hand side. When you get the y all by itself on the left-hand side, we have what's now called the slope-intercept form. And what that means is that when y is all by itself, there is no constant. There is no other number being multiplied by the y other than the number 1. Y is simply all by itself. Then over on the right-hand side, there is some constant being multiplied by our x variable. And then there's also some constant that's being added. So our slope-intercept form of an equation is y equals ax plus b. What I'm going to do is we're going to graph this equation, y equals 3x plus 2, and then we're going to come and see why the slope-intercept form is a particularly useful format with which to create our equations. It provides us some useful information. First of all, let's go ahead and determine what this line is. Remember, for this line, all we need are 2 points in this formula, in this equation, that satisfy it. And once we plot those 2 points, we connect them with the line, and there's our graph. Well, let's go ahead and choose x to be 0. Let's place this 0 back in the equation. 3 times 0 is 0. 0 plus 2 is 2. When x is 0, y equals 2. And so that's where that 2 came from there. So let's go ahead and plot our first point. Our first point is x0, y 2. So that's that point right there. Next, I went ahead and just chose the number 1 for x. I could have chosen any number, but I just selected 1. Well, let's put the 1 into the formula. 3 times 1 is 3, plus 2 is 5. So y equals 5 when x equals 1. So that's how we came up with this second ordered pair here. X is 1, y is 5. So we come to our origin, we come over 1 for the x, and then we go up 5. 1, 2, 3, 4, 5 for the y. Then what I'm going to do is I'm going to go ahead and connect these lines, or excuse me, these points to create the line. Here is the graph of the line. Now, let me ask you, where is the y-intercept on this graph? Well, if you start here at your origin, this right here is the y-intercept. Well, what is the value for y at the y-intercept? Well, the value is 2. Positive 2, as a matter of fact. Take a look back here at our slope-intercept form. Do we see what this constant is over here? It's 2, which matches our y-intercept. Well, let's determine what the slope is here. Remember, your slope is the rise over the run. You start at the point, you choose any 2 points, but you choose the point out of those 2 that's furthest to the left, and you start at that point to determine your slope. So from this first point to the second point, what is my rise? Well, my rise is 1, 2, 3, a positive 3. So my rise here on this first one is a positive 3. Rise over run. Well, what's my run from this point to my second point? My run is 1. The difference between 1 and 0, the x-coordinates of that point, is 1. So my slope is 3 over 1. Well, what's 3 over 1 the same thing as? Well, it's the same thing as 3. Well, take a look back here at your constant that's being multiplied by your x variable. It matches your slope. So some of the primary advantages of getting an equation into a slope-intercept form like this is, without even having to figure anything out, you take a look at the constant, a. Whatever that constant is that's being multiplied by the x is your slope, automatically. You don't have to do anything else to figure it out. And then secondly, whatever this b constant is here that's being added, that's your y-intercept. You don't have to do anything else to figure it out. That is your y-intercept. So that's pretty straightforward, and it's pretty neat how that works. Now, had I not chosen any values here, let's just go ahead and just kind of erase these here a little bit. If we had not chosen any values and plugged them in and calculated out what those ordered pairs would be, we can actually take a look here at our slope-intercept formula, and we can actually, with pretty little effort, plot this line. Now, I'm not going to actually plot it per se. I'm going to just show you what we can do. But let's for a moment assume that this blue line is not here. If we take a look at this y, this slope-intercept form, what does this plus 2 tell us? It tells us the y-intercept. So I could come down here right away and label my y-intercept right there. Then if I take a look at my constant that's being multiplied by my x variable, it's a positive 3. Well, if I remember that slope is rise over run, and this is a positive 3, that means I'm going to have a positive 3 rise over a positive 1 run. So I can come to my first point here, which is my y-intercept, and I can go positive 3, 1, 2, 3. That's a positive 3 rise over a positive 1 run, and I can actually locate my second point right there and connect them, and there's my graph. So actually, with the slope-intercept form, not only does it tell me my slope and not only does it tell me my y-intercept, but because of that y-intercept, I can automatically graph that point on the graph, because whatever the y-intercept is, the x-coordinate for that y-intercept will be 0. And then I just go to that point and I take my slope and I calculate my next point from that, connect the two together, and there's my graph. Okay, let's quickly move to our next screen here. Here we have a second equation. Now remember, our slope-intercept form says we have to have it in the format of y equals ax, some constant times x, plus a b. Well, there's no plus b up here. So how can we convert this equation in its current format into an equation that has a plus b on it without changing the value of this equation? Well, we can do it by adding 0. Remember way back, it seemed like a very, very simple principle, but we said that one of the characteristics of the number 0 was you can add a 0 to any number that you want without changing the value of that original number. So by adding a 0 over here to the side that has a 2x on it, we haven't changed anything. 2x plus 0 is still 2x. But now that we have this in a slope-intercept form, we can now take advantage of what it tells us. First of all, this constant over here, the number that's being added, tells us our y-intercept. Well, our y-intercept here is actually straight at the origin. Well, the next thing that we have here is our slope. So we can come to this first point here, which is our y-intercept, where x is 0, y is 0, and we can now, by using our slope, calculate or identify the next point. Remember, the slope is rise over run. And since our slope here is a positive 2, that's going to be a plus 2 rise over a plus 1 run. So I come here at my origin, my y-intercept, and I go up 2 and over 1. And I could go from that point, I could go up 2 and over 1. From that point, I can go up 2 and over 1. From that point, I could go up 2 and over 1. And so on. Now, it is important to note, I could actually come down here to my origin, and instead of going toward the right here, I could actually go left and down and still get a positive slope. Let me show you how. Our slope is 2, positive 2. But let's say I come here, and remember your slope is rise over run. Let's say I go down a minus 2. And then for my x, or my run, I go over a minus 1. My rise here is minus 2, and my run is minus 1. Well, what is minus 2 divided by minus 1? It's a positive 2. just like the positive 2 we have up here. So even though we typically start off by graphing by going toward the right, if I had done the same thing but going left, I would do my rise first, which would be a negative, and then I would do my run, which would also be a negative, and then two negatives counteract each other in that division and make a positive. So we can see that it's still a positive slope. So I'm going to go ahead and connect those points. There's the graph of the line y equals 2x. Y equals 2x. And remember, this plus 0 did not change the value of anything. Lastly, review the slope-intercept of the form of an equation is especially helpful because it helps determine the slope and the y-intercept of the equation for us. And lastly, the slope-intercept form of an equation is in the format of y equals ax plus b, where a stands for the slope and b represents the y-intercept. Okay then, that'll end session 42 on the slope-intercept form.